So we all just calculated our averages using the data from the table above of what each person rated their concert on a scale of 1 to 100. 100 is the most on how they enjoyed the concert. Okay, so we each went through and calculated the averages for when we did an SRS. That was method 1. Stratify by row, stratify by column. So these are all pretty like low bias because we did them randomly, right? Which of these three do we feel like is probably like the most like accurate? Or do we all kind of get like similar results? By row. We're all like grouped in here. Now, the reason why that was probably the best method, I think I mentioned this when we were on number 4 on the front page. We like said method number 2 would probably be our best because we're selecting 2 fans from each row. Now our strata was the rows. And then we kind of have like an equal amount of people in the front row as in the back row and the middle row. And you can tell by the numbers there. I can scroll up here for a second. It's not going to save my ink, but if I scroll up here for a second, obviously like the people in the front row rated the concert pretty highly compared to the ones in the back row. Okay, they enjoyed the concert more. They're right next to Justin Timberlake. So we're thinking the stratify by row was probably the best method for this type of survey for ranking the concert. Okay. But again, we are all within, pretty similar results. We didn't have any extreme like outliers where we're way down here, 60s are way up here, and then 90 or 100s, and that's because these are all examples of random samples. Okay, so low bias for all of these. Now we could go and calculate like the mean of all of these. Let's just kind of sketch in. So the mean would be we take all this data and divide it by how many of us did the survey. So I think 8 of us now took this in Olivia. But for this one, our mean would be somewhere pretty close to 78. Okay, 4 points above, 4 points below. This one, our mean would be just probably like right smack dab in the middle here. And we will go through later on and actually like do more calculations with the mean, but just for now, go ahead and just draw a line for that. There is like a true mean. The true mean from all 50 of these people was 78.38. So you can see how our means were pretty close. The stratified by column was a little bit higher results. And that was randomly selecting 2 from each column. And again, you could have, I think in mine, I didn't even have anybody in the back row by random number generator. So, okay, that's all I really need to do on that page. Now there's some kind of like follow-up questions to do here from this activity. And then I have another one where actually it's going to be pretty similar to this one. Yeah, that's what it's on. Okay. So important ideas from this activity we did. So these are all random samples. Which means there's low bias. And our goal was to choose a group or a sample from our entire population so that each individual had an equal chance of being chosen. And that's obviously what an SRS is. Every person has an equal chance of being selected. So choose a group. So that each individual, each content member has an equal chance of being selected. Choose a group of the population so that everybody has an equal chance of likely being chosen. Okay, so our three methods we used were SRS. So method 1, SRS. So our steps there are label, randomize, random number generator, select. That's why you're doing SRS. Assign everybody a number, which we did. We just numbered on 1 to 50, random number generator, and then select. The second method we did was stratified, random sample. And technically we did this for both 2 and 3. We just stratified differently. So just a little refresher over what that means. We split the population into groups of similar characteristics. Which we call strata. The group we call strata. And choose a simple random sample from each strata. Okay, that's what a strata is. So, in this activity we did the second time the rows as our strata, and then we did a simple random sample, meaning doing like the random number generator, and he like labeled the seeds 1 through 10 in each row. And then we did the random number generator to select 2 from each row. Okay, and then for the third method, we did a stratified random sample, but we grouped them by columns instead of rows. Okay, those are our big takeaways, and again, we talked about those like kind of in the notes. Here are some just like follow up, they call them check for understanding questions that you can kind of like apply what we learned in this activity to like these types of example problems. So let's just kind of go through these couple before we get into our next activity here. So this one says to score the AP statistics exams, ETS hires exam readers, table leaders, and other leadership. So kind of like 3 groups of employees here to score AP exams. Exam readers, table leaders, and other leadership. Each reading room consists of 16 exam readers and 2 table leaders. There are 100 reading rooms. The 18 members of other leadership work together in one room. Describe how to select a stratified random sample, of 36 people hired by ETS to score the AP statistics exam. Explain your choice of strata. Okay, so remember when we were like grouping people by this stratified, we want to group them in like similar characteristics and then randomly choose for each. So one way we could strata these people is by like their job title or whatever they're doing here. So we could call like exam readers one group, one strata. We could call the table leaders the other group, and the members of other leadership another group, and they don't have to be equal size, okay? And then we can randomly select a member from each of those groups. So strata, we want to group them similar characteristics. So let's use the employer's role or job title as our strata. Label and randomize. Each. those individuals would be selected for the sample. Okay. So maybe just put, you can even like do a drawing if you want. Group together is 16. Well, let's see, each group. Okay, so maybe, well, we could do math here later. Exam readers. That's one group. Table leaders. That's another group, and then these other groups. Now, here's another important characteristic about stratified random sample, is usually we try to select like a proportionate amount. So for example, we have 16 exam readers in each room, and there's 100 rooms, and we only have 2 table leaders in each room. So when we would do our selecting, a lot of the times we'd select more from the exam readers, and we want to keep it proportional. So let me just do like something like that. If there's a 16, you got 1600, 200 more, 1800, plus the 1800 members. That's about like 80% of our entire workers here are exam readers. So we'd select 80% of the people. If I want to do a sample of 36, I would select 80% of that from the exam readers. That's like the stratified sample. Okay, we're not going to get like too much more into depth with that, but we would select by assigning them all a random number. All the exam readers, 1 through 1600, they all get a random number. We would select 80% of the 32 people from the exam reader. Okay, is that going to make sense? And then we'd select, about 18% from the table leaders, and then there's only 18 members out of the other leaders. So that's an example of like how we could do a stratified random sample. Okay, so that's A. B says, describe how you do a cluster sample of 36 people hired by the ETS to score the AP statistics exam. Explain your choice of clusters. All right, so we didn't do a cluster in this activity. We're going to do it in the next one. But a cluster is when you basically just like group them, and then you just randomly select a group, and you're like, all right, I'm surveying all of you. So an easy way to cluster here would be by their rooms, right? We have 100 rooms that consist of 16 exam readers and 2 labels, but randomly one of the rooms is all of the other leadership. So they're already kind of like clustered together. So we would randomly assign like all the groups 1 through 100, and then randomly pick one. And then if we're only doing 36, 16 and 2, we have to select 2 groups then. So let the rooms be the clusters. There are 18 people in each room. So assign numbers to each room. And randomly select. We'll have to select 2 rooms and we want to get 36. All people in those rooms use your sample. Okay, see the difference between stratified and clustered? Okay. Explain a benefit of using a stratified random sample and a benefit of using a cluster random sample. There's one like pretty obvious downfall of the cluster sample, and that's this random room where like my 18 people of other leadership are working together. So if I end up not choosing that room, I never really get um, any opinion from these other leaderships, right? I like that with a cluster sample, there is like a majority, like it's more proportional. Like I'm surveying 16 exam readers and 2 table leaders. So if I randomly pick 2 rooms, like I'm getting a really good like proportional sample, which I can still do with the stratified. But like the obvious downfall of the cluster is you have this like random kind of group of other leadership, and they might not be represented in our sample, and they would be more of the stratified sample. So to just like quick put this into words, you don't have to write a lot here. I just put for like stratified. I said we ensure that people from every role are part of the sample, so we'll say all roles are part of the sample. Because remember, we're grouping them, that's our strata, we're grouping them by their role or by their job title. So we ensure that even if there's 1 or 2 of the other leaders, they will be a part and represented in our sample. This will give us a more precise estimate on the variable of interest. A nice thing about the cluster of benefits is that it's probably like going to be a lot more convenient. Like they're already grouped into rooms. Samples are fast and easy. You don't have to label every single person. You're just labeling the rooms. So I just put fast and easy. Only need to number the rooms. Not individuals. That was probably just like more convenient in this case. But stratified would give us a better representation of all the people involved of scoring the AP skills. Okay. On the funnel activity now. Okay. So I have like another one that's pretty similar, but now I think it does cluster sample, and it might even do. I can't remember now. Oh, yes, it does have a systematic sample too. All right, I'm gonna pass this out. So it's pretty similar. It's called How Much Do Fans Love Justin to like day 2. And we're just gonna do some other types of samples. So I wanted to do this today, but my computer felt kind of through. You guys are flexible. All right, so we can probably at least get this first one done here because we know how to do this, and it's the exact same method as the day 1 activity. So, okay, day 2. So first one, we're going to do a simple random sample. Same exact setup, but now we're in a different city. So they're probably going to give us some different data too. Nope, it's the same data. Justin Timberlake's concert promoter again wants to find out how much people enjoy his concerts. We're going to try some other types of samples versus just an SRS and a stratified. We're going to take it one step further with some of our new vocab. Okay, so same thing here. Label seats 1 through 50. What do we do next? To select our numbers. And SRS randomly generate. Yep. sloppy, just fast. Second step, yes, we're gonna do our random number generator. And then there's our sample. Select person. That's our sample. Okay. So let's each do that quickly. And then we can pick it up tomorrow with our data. Random.org 1 through 50. Still selecting 10 people. Once you get your 10 numbers, you can select those people. So I can always get people at the right speed. Okay, we'll stop there. Get your data for first one, and then we'll go on method 2 and 3. We are going to do a couple different methods.